Hello everyone, this is Zhang Weizheng from National University of Singapore. Today I am going to present our work on ICCB 2023, Preventing Zero-Shot Transfer Degradation in Continual Learning of Vision Language Model. I will first provide some background knowledge, then I will introduce our method. Finally, I will show our experimental results. Nowadays, vision language models are very popular and show great performance. Our first question here is, why do we need continual learning for vision language model? There are two reasons. First, the performance on some tasks is poor due to insufficient relevant image text pairs in the pre-training datasets. For example, it is difficult for Calib to distinguish between digital numbers with an accuracy of minutes below 60%, which is much lower than a naively trained CNN. Second, if we want to expand a model's knowledge, we can retrain the model by adding new classes to the training dataset. But retraining a large model is costly. The second question naturally arises, why not existing continual learning methods works? First, existing methods hardly prevent the forgetting phenomenon for zero-shot transfer ability in continual learning of a pre-trained vision language model. For replay-based continual learning method, the dataset during pre-training may be private and inaccessible during the fine-tuning process. While for distillation-based continual learning methods, they do not lay enough emphasis on the pre-trained models. Now, let's compare between traditional continual learning and continual learning with the pre-trained vision language model. In traditional continual learning, each task is handled by a specific task head, while vision language model's text encoder can handle infinite number of potential tasks. This is very different from traditional setting. Our method consists of two parts: distillation in feature space and weight ensemble in parameter space. First, for distillation in feature space, we choose a rich semantic. This could be unlabeled, image dataset, for example, ImageNet, and texts, for example, contextual captions as reference dataset and reference text. We choose zero-shot model. Here we choose original clip as the reference model and use the reference model, reference dataset, and reference text. We can calculate the distillation loss. The left figure here is the loss computation for our distillation in the feature space, while the right figure shows how our method protects the feature space during pre-training. On the other hand, machine learning models integrate learned knowledge in their parameters. To mitigate the forgetting problem, a series of works imposes regularization losses on the changes of parameters. The model among training compose a sequence of different learning forgetting trade-offs. Instead of interpreting only between the initial and the final model, which is proposed in the WISE paper, our method weight ensemble averages the weights in the sequence during the training time to obtain a better trade-off. Traditional continual learning setting is too easy for vision language models. Thus, we propose a harder benchmark, multi-domain task incremental learning. The left figure shows that this MTLI benchmark consists of tasks from different domains, while the right figure illustrates how to calculate metrics of transfer, average, and loss during the continual learning. Detailed explanation can be found in the paper. On this benchmark, our ZSCL method outperforms previous methods on almost every metric, and our method also improves the traditional class incremental learning performance. To summarize, we point out a new problem, propose a new benchmark, and propose a new method which outperforms all state-of-the-art methods across multiple benchmark datasets. Thank you for your listening.